Hello guys and welcome back in Marketing Mix Modeling 101, everything you need to know about marketing mix modeling. I'm your host Christian, and in this episode we will be in the pre-modeling phase, and specifically we will cover data validation and data review. As we said in the previous episode, we will not cover data collection, as this is basically more a matter of the technologies that you choose to use. So in case you are curious about learning more on data collection, just let us know down in the comment. We will be more than happy to create new contents about that. But for now, we will move directly on to data validation and data review. And specifically in this episode, before covering the basics of data validation and data exploration and review, we will talk a little about common terms and data formats for marketing mix modeling, because we want you to have a clear picture and know what you are talking about whenever you will hear terms like dependent variable, independent variable, intercept, and stuff like that. So let's start right away. The first term that we have already heard a little in marketing mix modeling is regression. And specifically, the very first type of regression you'll probably find yourself using, and the basic one, is linear regression, which is a basic approach used to describe the relationship between two or more variables. This is a simplistic definition. You can find more if you're curious, but basically at this point you maybe ask yourself, okay, but what does this mean in real world? And imagine you have a chart like this, okay? On the x-axis you have dates, so every month of the year from January to June. Then on the y-axis you have your sales in $1 million, okay? So on January you have generated around 1.5 million sales. February was a little lower, around 1 million. Then March was a great month because we went up to 3 million and so on, okay? So these red dots represents how many revenue in terms of $1 million we have generated over each month from January to June. Okay, now linear regression basically tries to find a line that is as close as possible to each and every point, okay? So we take this chart, we derive an equation that draws this line. And this line, as we just said, tries to stay as close as possible to each and every point on the chart. And this is the linear regression itself. And we can use this in order to understand what's going to happen in the future. Because as you can see, our line here is going a little over the end of our dates. You know, our data is only up to June, but you see the line is still going. And so what we can do here is, okay, let's add another month of data. Let's add July. And you see that's a new dot over here, because basically what you can use the linear regression for is ask it to tell you, okay, what's going to happen if I add another month of data? What's going to happen next month on July? And if you just add July and then find the point where July intercepts this line, you will see that you'll go from June, where you have approximately, we can say, I don't know, $4.7 million, up to probably $5.1 million. So it's still growing. It's a growing trend, okay? And this is the basic idea behind linear regression. And this line is derived from an equation, which looks something like this. It's y equals m plus beta 1 times x1 plus beta 2 times x2, and so on, okay? Because now this is a really, really simple example over here, but once you start adding more variables, you will have like 3D, 4D, 5D, and dimensions. So it's not really easy to represent it over here, but basically, once you start adding more variables to describe your sales, so you start adding your Facebook expense, your Google expense, maybe organic sessions, then product prices, and so on, you start basically adding more variables into the linear regression. And x1, x2, and so on, every x represents one variable that you add to the model. And the betas here are just the coefficients of the actual variable. So they represent basically the impact of the variable. But let's go with an order. So first thing that's important to understand here is what does the y mean? and I'll move myself on the right side for a moment. Y is the dependent variable, and it's called so because if there is any kind of change in any other variable of the equation, that's going to affect the y. So that's why it's called dependent variable. And specifically, our dependent variable is the variable that we want to predict, that we want to model using marketing mix modeling, using linear regression. So in this case, the sales is our dependent variables, okay? And then x1, x2, xn, in terms of how many x's we have, is called the independent variable. And that's because if there is any change on any other variable in this equation, those will not be affected, because basically x1, x2, and so on are the data that we give as input to our model. So our Facebook expenditures, our organic sessions, and so on. And that's not going to be affected by changes in any other variable, because those are just ground truth data, basically. Then we have this m. M is called the intercept. And to make it as simple as possible, it is the point where this line touches the y-axis. So you see, it's not actually intercepting at 0. It's probably, I don't know, 0.2 maybe. And that represents what happens if I provide the model 0 on any other variable. Am I still going to generate some sort of sales? And that's represented by the intercept, because if the intercept is 0.2, it means that if I'm not spending anything on Facebook, on Google, I'm not generating organic sessions and so on, I will still be generating 0.2 million euros per month, for instance, okay? So this is the intercept. And as we said earlier, the last part of this equation is actually beta 1, beta 2. I have not connected these two here just for the sake of this representation, but this applies, of course, to all the betas that you have in your equations, and those are called the coefficients. And as simple as it gets, coefficients represent the impact that each variable has on your revenue. Because you see, this is actually an additive formula, you know. So you add m to beta 1 x1, beta 2 x2, and so on. And imagine you do all the multiplications before. So you do beta 1 times x1, and you'll get the value. Then you do beta 2 x2, and you'll get the value, okay? Then you sum everything up. Once you sum everything up, you get y, which is the whole revenue generated, the whole sales generated. But if you take these values one per time, you'll basically see, okay, hem is generating 0.2 million revenue. Maybe beta 1 times x1 is generating 0.8 million revenue. So you will know that Facebook ads is bringing that portion of sales, that share of sales, basically. And that's what the coefficients are used for in the linear regression. So now that we have a clear idea of what linear regression means and how it works, we can move on to a basic and general data formats for marketing mix modeling. As you can see here, this is a ready-to-use dataset for marketing mix modeling. And specifically, you will see the first column, which is date. And this is basically weekly data. So you will see the starting date for each week, okay? So we have one row per week. And on each row, we have several columns. We have our revenue, which would be our dependent variable, the variable that we will model on and that we want to forecast, okay? So this is the revenue generated in the whole week. Then we have how much we have spent on TV on that week, how much we spent on Facebook on that week, how many impressions that Facebook spend generated on the week. Same for Google, and on this time we have Google clicks and not Google impressions. Then we move on and we have competitor sales, which is another external variables that we may use. Then we have events, and as you can see, we basically have or either no events or maybe event 1, event 2, and this is called a context variable, basically, which doesn't have a numeric variable. It's a variable that is contained into a specific and close set of values. So you will not have like 0.5 here. You are either going to be no events, event 1, event 2, or event 3, for instance. So you know that there is a set of values that this variable can have, and that's only those set. This is called a context variable. And then you have, for instance, how many sessions you have generated via your newsletter. And this is cool because, if you get a data set like this, you can start modeling right away. But more often than not, you will start with something like this. Let's say you use Shopify and you want to export your revenue week over week, and you get with something like this, 1 row per week and the revenue generated on that week. Then you go over to your Facebook Business Manager and you export the data from Facebook, and you'll get a different format because you still have your spend and impressions, and it's actually weekly data, but as you can see here, the date format is different and you are missing some row. And so these are all things that you will need to address before being able to merge your Facebook data with your revenue data, because if the date format is different, you will not be able to merge those. And if there are missing rows, that's going to cause problems. So you must be able to address all of this. Then we move on to Google and we export our Google data, and we see even another different situation, because now the date format is correct and the rows are correct, but we don't have weekly data, we have daily data. So before being able to aggregate Google with the rest of the data, we will have to work on the Google data alone itself in order to aggregate the daily data into weekly data. So that's another thing that we must be able to do before being able to get our final data set that is ready to use for modeling. And basically, all of these actions may take our data, may generate discrepancies in our data, because once you start formatting, merging different files, you may actually do some mistakes. Some rows may be left out, some may be aggregated in a wrong way. So it's important that you follow a series of iterative checks in order to be 100% sure that your data stays the same, stays correct, and so on. And we say iterative because these checks must be repeated each and every time that you do any kind of actions on your data, because the discrepancies could arise on the first match as well as the second, the third. So you just can't do it on the first one and the last one, because then if there's a discrepancies, you will have to repeat everything again. So do this iterative on every step of the merging, on every step of the formatting, and you will be 100% sure once you get the discrepancies where it happened, and it will be a lot easier and a lot faster to debug this. So imagine you start with 2 different datasets, such as the revenue and Facebook, okay? The first thing that's important to do before even starting working on merging and formatting is always keep a copy of the raw files, because that's going to be a lot easier whenever there's any discrepancies to go back and start from a fresh point, from a point that's actually correct. Then, always before even starting to merging and so on, in order to be sure that where our issues are coming from, we need to be 100% sure that the raw data is correct. So you want to compare your raw files very carefully with the actual sources where they're coming from. So let's say with the Business Manager dashboard, or maybe with the Shopify dashboard, so that you are 100% sure that the raw files themselves, the one that you just copied basically, are good. Because once you start merging, if discrepancies arises, at least you know it's in the merging action, not earlier. So you want the copies of the raw files to be ground truth. Once you get that right, you can start merging. And once you start merging, basically, there are a few things that you can check for. And really easy. I'll move myself in the middle. I think it's the best place here to not cover anything. So there's a simple validation checklist that you can follow over here to ensure that both when you're checking your data with the raw data and when you're start merging data, you are sure that there is no error. So the first thing that you can do is actually count the rows before and after, and do like sum and mean of specific columns. So maybe sum the total Facebook spends and the average Facebook spend, and then compare those to total Facebook spend on Business Manager and average Facebook spend on Business Manager. And that's for the raw file, as well as this works for both comparing the raw files to the sources and comparing like merged file with with the files from the step before, basically the unmerged one, okay? So first thing that you can do really easy, really quick is row count, sum, and min of the columns. This way you'll be, it's easy to find out if you are missing any row, if any data is getting corrupted or maybe duplicated and so on. If this stay the same before and after, exactly the same, then you'll be already pretty confident that no issues have happened in the merging process, okay? Then once you keep merging, another thing that you can do is a time series plot of before and after. So imagine it's simple as it gets. You just do a time series plot where you have your dates on the X, and then you put your Facebook spends, for instance, on the Y-axis. And then you'll get a line of how the spends on Facebook behaves over time, basically. And you do this for the raw file, for the first merged file here, for the second merged file here, and the line must be exactly the same because, okay, you're merging, of course, but your Facebook spend, it must be the same before and after merging. If I merge my Facebook spend with Google, that's not going to impact my Facebook spend. Those are going to be two different columns that I just need to have them one close to another, basically. So time series plot is another great way to get a visual impact if there's any issue, because if you see the lines are not aligning perfectly, you see imperfections, you may go deeper and see, okay, what's happening in that specific week where I have this peak on my merged file, which is not present in my raw files, basically. And what you can do is once you merge the first two into the second one, then you are sure that this one is working. Once you go for the third merging, for instance, it's okay to compare this to this one. But again, if you want to be 100% sure, you may even compare them all the way down to the bottom. So to the top, sorry. So let's move on to, these are basically some data validation things that you can do in order to ensure data integrity and the correctness of the data, basically. And now we can move on to the data exploration and review phase. And as you can see up here, this phase is meant to let you know the business through its data. So it's really important that you try and get the most out of this phase in terms of business knowledge and understanding things that happen in the business through the data. And your main goal is here, just like we said, is in fact this, learning as much as you can about the business. But not only that, once you start learning, once you start seeing the data and understand more about the business, you want to get a clear idea whether or not the data that you have chosen so far and that you have collected so far can actually answer the desired business questions, the ones that we defined in the very first step of the project, where we define the scope of the project, basically. Because if you already find some issues here answering those questions, it can really be an issue later down the road. So at least here we still have some margin of correct data, maybe get some extra data that we didn't think of, okay? So there is a series of analysis that we can perform in this phase to start getting an idea of the data and understanding what's happening. And the first thing will be, oh, sorry, my bad. Okay, some spoilers of the next ones. Never mind, okay. So the first thing can be a correlation matrix. So you basically take all the variables that you have in your dataset and build a correlation matrix. And as you can see here, we have variable 1, 2, 3, 4, 5, and so on. And then we have from top to bottom, 11, 10, 9, and so on. And you see this part of the matrix is not filled just because it will be the same, just replicated, basically. And this line here, where it's 1 all the way, it's because it's where V1 matches with V1 and with V2 and so on. So the correlation here is, of course, 100%. Then what you see here is a value of the correlation between a variable. So for instance, we can see that there is a really strong correlation between the variable 9 and the variable 10. And this may mean that one thing that can happen is the business you are modeling on maybe is strong on Facebook ads, okay? And there is a strong correlation between Facebook ads and Google organic sessions, because maybe a lot of people see your ads on Facebook, maybe on the mobile, but then they choose to search for the business on Google when they get back home, when they finish working, for instance, and do that from their computer maybe because it's a high product price and they want to get more information before doing the buying basically. And so there may be an high correlations, and it's important that you find out because this will start giving you an idea whether or not there is maybe multicollinearity in your model. So you can start thinking, okay, how may I actually handle that if that comes out that there is too high correlations here. Maybe you can use some modeling techniques that we will see in the next video to handle multicollinearity. Maybe you can do I will not go too deep into this because I don't want to spoil you, but just to give you a few names, maybe if you are curious to learn more, once you, in the time we will share more contents, basically you may use ridge regression or hierarchical model, stuff like that. So it's important that you start understanding whether or not there is these high correlations with variables. And this is useful because you may find out some correlations that you didn't think of, okay? And then once you get this right, you may move on to pair plots, and you may actually pair plotting your dependent variable, so your total sales, for instance, with all your other variables. And as you can see here, the points basically represents the cases in which, for instance, we had a product price, an average product price of $250, and we generated the sales. And as you can see, we mostly didn't do anything when it was 250. We did a lot of sales when we have an higher average price, so up to 300, 400, and 500 approximately, you will see a lot of sales. There is so many, basically there is so many points, there is so many data showing us that $500 as an average price works well. We generate tons of sales. And then even higher, this is about 700, 650. That's a lot of sales. We sold really high revenue. We generated really high revenue. But as you can see, there are less points. So it means that maybe there are some more going on when we generated these high sales. Maybe there were holidays or something like that. So one thing that we can get from this plot is probably that 500, average price of 500, is actually the sweet spot maybe for our product because that's generating a ton of sales. So independently whether or not there is an holiday, we are spending more on Facebook, probably the $500 is what our customers are more willing to pay for our products, for instance. So, and you can do that for all the other independent variables and start getting an idea what's the sweet spot maybe for Facebook spends and so on. And then about this specifically, what you can do is do OLS, logarithmic trend line between, for instance, sales and your paid media. And so as you can see here, we have our Facebook cost, how much we're spending on Facebook ads, and how many sales we are generating. And again, these points just represent, okay, and this time where I spent $15,000 on Facebook in a week, I generated approximately 200,000 euros in sales, okay? And what you get here is a first look of what your Facebook diminishing return may look like, the saturation curves of Facebook. So you see there's from 5,000 to 10,000, there is like this a lot of growth here. And then once you get to the 10,000 point of spends, the curve starts to flatten. So we generate less and less and less revenue from Facebook. So what we get from this plot is probably that 10,000 is our Facebook saturation point. That's something that you will get a better idea later down the road during the modeling phase for sure. But starting to analyze these kind of things will give you the power to do the modeling phase with a lot of idea, a lot of hypotheses that you will want to validate during the modeling phase. And basically, that's it. So you get an idea of your saturation curves per paid media channels and maybe the saturation point and so on. And then you can do some time series analysis, for instance. And In this plot specifically, as you can see here, we have our blue line, which is our revenue over time from a span approximately from the end of 2016 to the end of 2018, okay? And this is our revenue basically week over week. And then we have plotted our paid media variables in terms of how much we spent week over week on those media. And what we are trying to understand from this plot, some insights that we can get out of this plot, is looking at the peaks at the in the revenue, okay? And you see, for instance, there is a high peak in revenue, and there is this high peak on this red one, which is TV spend. So one thing that we may get from this is that probably TV spend has a high impact on our sales. Or again, there is these peaks over here on the green line, and there are these peaks on the revenue. But as you can see, it's a little moved on the right side. You have the green peak here and then the blue peak here. And the green peak is radio spend. So we spent a lot on radio, and then probably the next week we generated a lot of sales. So what we can get an idea of here is actually that maybe the radio doesn't convert right away. Maybe it converts the week after, because people start hearing about us on the radio on the way to work, for instance, and then they forget about us, or maybe the weekend they will search about us again on Google, find out and buy. So there is this a little lag between when we spend on radio and when the revenue is generated. But again, we see actually a correlation here between spending a lot on radio and generating a lot of sales. And again, here you can see the same thing. And that's basically what you can do with this kind of time series analysis. And of course, you can choose to put more or less variables. You can do this maybe with your organic session and see if there is a correlation and so on. Maybe with organic sessions and your media spends, for instance, and trying to understand whether or not you are driving organic sessions from your paid media. And so that's basically it for this episode. We have covered a lot of things. We have talked about quite a few important things that you must be doing during the pre-modeling phase. And I would like to just do a quick summary of what we have talked about. The first thing is that, as we said, MMMs are mainly powered by regression analysis, and we got a general idea of what linear regression is, which is the basics of regression analysis. What are the important terms in linear regression, such as independent variable, dependent variable. You will be hearing a lot about those during your marketing mix modeling project. So it's important that you have those clear in your mind. Then we talked about checking your data each and every time after your exports, after each aggregation step, and so on. And then one thing that you must keep in mind during the review phase is that you must use that phase to learn as much as you can about the business. You don't just want to go over and execute everything because, Christian told you in this course or you've seen a blog post, and that's really going to make it useless, because the review phase is meant to learn about the business. It's meant to learn the data, about the data. You want to get as much as possible out of those data, and you want to formulate hypotheses that you will be validating during the modeling phase. So this is really important, that you just don't turn your brain off and execute and do plots to show your stakeholders. It's important that you learn from the data, because that's going to give you, your stakeholders, your team, your client, a lot more insights than you can think only from that phase. So I will not stress that enough. I will never stress that enough. It's the review phase, the data exploration phase. It's so important. Just do it right and you'll be 5 steps ahead in the modeling phase. And then one other thing that you must keep in mind during that phase is actually understanding whether or not the data is suitable for answering the business question defined in the first step of the project. Because if not, that's probably your last chance to ask for more data to your clients, because otherwise it's going to really be tough to get new data during the modeling phase and still keep up with the deadlines that you set up. So that's all for this episode, guys. In the next one, we will go straight into the modeling phase. We will talk about modeling techniques, we will talk about feature engineering, and model optimization, selection, evaluation. That will be a really full of content episode, basically. Thank you so much for watching, guys. If you have any questions whatsoever, feel free to comment below, get in touch with us. You will have our LinkedIn profile in the description. So don't hesitate, guys. We are really glad to answer any kind of question and help you out as much as we can. So thank you so much, guys. I'll see you in the next episode. Bye.